Today we're talking about a minuscule particle that's been called a lot of things. The Higgs scalar,
The Higgs field quantum,
the Brout-Englert Higgs boson,
the God particle.
and to put it simply, the Higgs boson.
Now, I know what you're thinking. Why should I care about some tiny particle? And I get that. Particles like these are so far removed from our daily lives that they just don't matter to us.
Yeah.
Or so we thought.
So the real thing is that this little guy has a pretty big role in making sure the world works the way it does. First things first, let's break down the basics. Have you ever wondered about why things have mass?
Yeah, why do you fall off when you jump off a terrace?
Oof, Roblox oof sound.
Or why does your school bag full of books weigh you down? It's something most of us take for granted, right?
Yeah.
But this question puzzled scientists for ages. Like why do some things have mass and some other particles like photons don't?
And we're not talking about gravity. Gravity is correlated with weight. We're talking about mass.
And this is where the Higgs boson comes into play. Picture the universe like a giant invisible field, what we call the Higgs field.
Yeah.
It's everywhere, surrounding you, me, Arnav, everything basically. Particles that interact with this field get slowed down, and that slowing down is what gives them mass.
Imagine trying to run through water. It slows you down, right?
Yeah, a lot. Plus, it's like really hard.
That's pretty much what happens to particles in the Higgs field. And that's how they gain their mass.
And what about the Higgs bosons themselves?
The Higgs bosons are like the ripples in the field. They're not like an actual part of the field, but they prove that the field is real because they're the ripples in it.
I know, it sounds a little wild, right? An invisible field that gives things mass.
Ooh,
But
yeah.
when you come to think about it, without mass, nothing could exist as we know it. No Institute for Advanced Study,
No Edward Witten.
no MIT, and everything.
Yeah. So the Higgs boson, in a way, is like the universe's glue. It makes sure that things have substance. Even you wouldn't be existing right now because, well, nothing would hold you together. So let's talk about the Higgs field in a more down-to-earth way. Imagine you're at a concert and you're trying to move through the crowd. What was that? Wait, what was that recent concert we had like a couple of weeks ago? Like we didn't attend it, but it was there. In
There
Mumbai.
was no concert. It was like people were mad over getting tickets for some Coldplay concert. That's in January.
Coldplay. Oh yeah. Okay.
What,
So
man?
so let's talk about that.
Too much physics you're reading nowadays.
So if you're a big famous celebrity like Dwayne Johnson or whatever, people will notice you, crowd around you, and they'll slow you down by asking you for selfies and all. So that's like how big particles like protons interact with the Higgs field. They get slowed down and they gain mass.
Now, picture someone else moving through the crowd. Someone like me or Arnav.
Yeah.
I mean, no one will notice us and we can slip through without getting slowed down. That's like a photon, which doesn't interact with the Higgs field and stays massless. So, how much attention you get in the crowd is kind of like how much mass a particle has.
Doesn't sound so mysterious now, does it?
Yeah, and this was actually thought of back in 1960 by a guy named Peter Higgs along with a few other brilliant minds from the Institute for Advanced Study at Princeton. And they suggested that this field existed. But no one had ever seen it. It was just an idea, a sort of a nice theory.
Yeah.
And theories are cool, but you need proof, right? So you fast forward to 2012, and that's when the Large Hadron Collider, or the LHC, finally found it.
It was like finding the universe's missing piece. Like, it confirmed this wild idea from the 1960s. So, let's talk about the 1960s then. So, Peter Higgs was a relatively unknown physicist at the time. He was working on this mind-bending idea that there was some kind of field permeating the universe that gives particles their mass. And at first, no one really paid attention. I mean, it was the 60s. People were talking about moon landings and not invisible fields. But Higgs, along with a couple of other scientists, were like, they stuck with the idea.
And here's the funny part. Higgs didn't even set out to become famous for this idea. He wrote a couple of papers basically saying that he thinks there's this invisible thing that gives stuffs mass. And at first, his ideas were kind of brushed off. And one of his papers was even rejected.
Rejected, actually.
Yeah. And imagine that, one of the most important scientific ideas of the century. And people were like, nah, we're good.
Out, can.
Wait, haven't we seen this somewhere else?
Yes. It starts with E and ends with Einstein.
Yeah, Albert Einstein and his rejection of famous ideas. Nuclear fission. No, can't happen. Nuclear energy, not possible. Quantum mechanics, out. But we all know what happened.
Yeah, we do. So, over time, people started to realize, unlike Einstein, that this idea actually works. Okay, it actually did explain some major gaps in particle physics, like why some particles had mass and others didn't. So, later on, this did become one of the cornerstones of the standard model of particle physics that we use today. So, that time it was still just a theory, though.
Yeah, and you fast forward to the 80s and 90s, and scientists were like, okay, we got this big theory now, but where's the proof? How
Yup.
do we show that this thing that we can't see exists?
Because science is based on evidence, right? TOK.
Yeah, correct. So that's where the LHC comes in. It's this enormous machine that was built in part to test Higgs's idea. And it took until 2012, almost 50 years after Higgs first proposed it, to finally find the Higgs boson.
And get this, by the way. Peter Higgs was so sure that the discovery wouldn't happen in his lifetime, he didn't even attend the announcement.
Huh?
He was having like lunch or something while they found the Higgs boson.
Shit, this
He
guy was totally surprised by the timing that means.
Yeah, it's all thanks to the wonders of LHC.
Okay, wait. But I think we should talk about the LHC for a second.
Sure. It's
And-
massive though.
Yeah, you might have heard of it. It's that, as Arnav said, massive underground ring in Europe where scientists smash particles together. And when I say massive, I mean massive. It's,
Really massive.
yeah, it's 100 meters inside the earth and it's a 17-mile long tunnel. Imagine building that just to understand particles so tiny you can't even see them. But that's what scientists did. Because finding the Higgs boson was like searching for a needle in a cosmic haystack.
That's like a Dadaji joke, but okay.
Shut up.
So, when they finally detected the Higgs boson in 2012, it wasn't like, oh, there's a particle just sitting there. It was more like, oh, so we smashed these particles together, something weird happened, and we saw the aftermath, the decay of the Higgs boson. And from that, they backtracked it, and they knew they found it just from the aftermath. Because it only exists for a fraction of a second. It's like, I think, nanoseconds, if I'm not mistaken.
Yeah.
Before it just falls apart into muons and other stuff. So that makes it incredibly hard to spot. But that tiny moment was enough to confirm that this invisible Higgs field, the thing that gives particles mass, is real.
And let's take a second to appreciate what mass really is. When we talk about mass, we often confuse it with weight. But as we stated before, they're not
Yeah.
the same. Mass is a measure of how much, to put it crudely, how much stuff is in an object. While weight depends on gravity pulling on that mass. So on the moon, your weight is less, but your mass is constant wherever you go in our universe.
Yeah, regardless of the gravitational attraction upon you.
Correct.
So why does this matter? Because mass is what allows things to exist with structure. Without mass, particles would just zip around at the speed of light. There wouldn't be any like resistance to motion, right? Like photons, that's what they do. But nothing would stick together. There wouldn't be any atoms, molecules, chemistry, biology. Wait, no us.
You forgot physics?
No, physics is like just on the top.
Okay.
Mass is why when you drop your phone, it doesn't just float away. It just falls and smashes into a million pieces because of the Earth's gravity. So blame gravity for that.
The Higgs field is like a universal, you can say, net that catches particles as things move. And how much they interact with this field determines how much mass they have. If a particle interacts a lot, it is heavy, like a proton or a neutron. And I know, when I say heavy,
I mean relatively heavy.
Yeah. Okay, if it barely interacts at all, it is like a photon, which is, as we said
And
massless.
in the case of a photon, it's like no interaction because it's massless. So, if you've understood till now, you might still ask, why should I care? How does this affect me? The same question we asked earlier. And that's the same question we asked an electron. It was asked of quantum physics as a branch of our understanding of the universe. And you know what happened later. Today, quantum physics is the foundation of the whole information technology revolution. It's like the fourth industrial revolution and all that. And finding the relevance of this mass thing may also take us decades from now as well.
But as our good friend Neil deGrasse Tyson responded to the question of how does it put food on my plate? Well, we can say that civilization stalls in that moment. So as patrons of science, we need to be content with discovering something new without regard to its relevance to civilization, because history has shown us that if we give it some decades, civilization finds a way to tax it.
And here's the thing. We live in a universe where everything is built on particles. Literally everything. The fact that things have mass means that the world can exist the way it does. Stars can form, planets can orbit, and we can sit here and chat on this podcast. All because particles have mass. And mass only happens because of this field that the Higgs boson proves exists.
Without the Higgs field, none of that would exist. There wouldn't even be atoms because the particles that make them up wouldn't stick together. It's like trying to bake a cake with no flour. There's nothing to hold it all in together.
Or like making fries from potatoes.
Yeah. Without potatoes, na?
Yeah, without.
Arey yaar.
Same thing. Same
So,
difference.
Yeah. It might seem like this discovery is just about some tiny particle, but it's actually a big deal when you think about how fundamental it is to, well, everything.
So what I find amazing is how long scientists were looking for this thing. I mean, Peter Higgs came up with the theory in 1960s, as we said earlier, and we also said that it took around 50 years to prove it. But that's a lot of patience, I gotta say.
But that's science for you, right?
Yeah,
It's not
fair.
always about instant results.
Yeah.
It's about understanding the world in a way that might take time, but it eventually leads to answers about the universe itself.
And just because we found the Higgs boson doesn't mean we're done. In fact, it's opened up a whole new set of questions. There's still so much we don't know, like what makes up dark matter. I mean, we technically do know that. We've spoken about it in the last episode.
It's just a big mystery.
So, or why the universe is expanding faster and faster. The Higgs boson is just one piece of this puzzle, and we don't even know how many pieces the puzzle has. But it is helping us figure out where to look next.
Okay. Just before signing off, here's
Okay.
a Higgs boson joke for you. Okay?
Okay, another Dadaji joke. Please no.
Just listen to it.
Okay, I'll tell you if it's after the joke.
Okay. Imagine a Higgs boson entering into church. The priest tells him or her, no discrimination.
The Higgs boson.
Yeah, the priest tells the Higgs boson, I'm sorry, but no Higgs bosons are allowed here.
Discrimination against Higgs bosons.
Yeah. So, the Higgs boson will reply, I'm sorry, but without me, you can't have mass.
Wow, so funny.
I
But
mean,
as I said, it was a Dadaji joke.
That was a good one, man. Come on.
Okay, sure. But finally, there you have it. The Higgs boson might be a small particle, but its impact is massive. Like literally, it's mass.
Massive.
Yeah. My turn for a Dadaji joke. So it's not just some obscure particle, it's a key to understanding why the universe holds together the way it does. And without it, the world as we know it wouldn't exist.